Hey everyone, we're here today to look at an example problem in thermodynamics. And basically this is a conduction type problem where we have two materials in contact with one another and we're going to look at how they transfer energy from one thing to another. So let's go over and take a look at how to do this. So we have a half a kilogram piece of metal at 100 degrees Celsius and it's placed in 2 liters of water. That water is at an initial temperature of 20 degrees Celsius. The water and metal reach thermodynamic equilibrium, which basically means that all that energy has been transferred from one thing to another. They are at the same temperature now. And that happens at 30 degrees Celsius. What is the specific heat of the metal? All right, so any type of problem like this, when we want to talk about thermodynamics, we want to separate the problem into kind of two parts. And the two parts are the materials that we're dealing with. So the first type, or the first thing that we have here is the metal. The second material that we're dealing with, or substance here, is water. And so what we're going to do is we're going to write down the things we know about these objects. So let's see, for metal, we do know its mass. We're told its mass, and that is, let's see, it's 0.5 kilograms. We are told the metal's initial temperature. So the temperature at the beginning is 120 degrees Celsius. Let's see here. I guess it looks like whenever it gets to its final temperature, it's going to be at 30 degrees Celsius. All right, that seems to be the information that I know about my metal. So let's go over here to the water and talk about the things we know here. So we have 2 liters of water. So that's kind of like a volume of water. We have, let's see here, I guess its original temperature, or it's a temperature at the beginning here is let's see, what is it at? There we go. Looks like it's right here, 20 degrees Celsius. Of course, because it's ending at the same temperature, again, thermodynamic equilibrium, it's going to be the 30 degrees Celsius. And let's see, do we know anything else? Oh, this is just something you need to know about water. Water has something called, in fact, all materials have this thing called specific heat. The specific heat for water happens to be 4,184 joules per kilogram degree Celsius. So it does have kind of strange units. This idea of how much energy it takes to heat up or cool down, for that matter, a certain mass of material at a certain temperature. So this is our specific heat for water, and again, because this is a property of the water, this is going to be the number we use for water all the time. And here we are, of course, talking about liquid water, not ice or not water vapor. Those would actually be different. Now notice here, the question that's being asked, it says, what is the specific heat of the metal? So the find for this problem, what we're trying to actually find here is this value here. This is our question mark. This is our value that we are trying to find. All right, so let's talk about the equation here when we talk about how to actually solve this. And here's basically the idea. What you need to keep in mind is that the metal actually tends to lose energy, and the energy that the metal is losing is what's actually gained by the water. And again, that's because they're in contact with one another. Through the process of conduction, we have the transfer of energy. So basically, if I look at the metal, the energy, or the change of energy that it has, is going to be equal to the change of energy of the water. All right. So again, what we're going to have here is that the change of energy, again, the water is going to be gaining energy, and the metal is going to be losing energy. So actually, a real quick note about that, because it's losing energy, we should put a negative in front of it to indicate a loss of energy, or it's a negative change. In the end, we have less energy or less thermal energy for the metal than that. So to keep these two things equivalent, we're going to need to put that negative sign there. All right, so the type of energy we're dealing with here is thermal energy, and thermal energy can be thought of as a mass times the specific heat times the change in temperature. And again, this is all information for the metal, so I guess I should put subscripts here. These are all metal information. Over on this side, again, it's the mass of the water times the specific heat of the water times the change in temperature of the water. So let's take a look at these equations. I think we're getting this down to a point where we should be checking what we knew about the problem. So I'm just going to kind of go through, mentally check here. I do know the mass of the metal. I don't know the specific heat of the metal, but that's okay because that is what I'm trying to find. I do know the change in temperature of the metal, so that's okay. Mass of water. Weren't told that. I know I have a certain quantity of water, but I don't know it. And I do have the specific heat, and I know the temperature change here. So the fact that I have two unknowns in this equation, that's going to be a problem. This is what I call a red flag. We need to know the mass of the water. So I'm going to go back to those original knowns. We're going to talk a little bit about how we get the mass from there. Okay, so we're going to talk here real quickly about how we get mass from volume. And this is another thing about water you need to know. Water has a certain density, all right? And the density of water, let me try that again. Density of water is 1 kilogram per liter. All right, so if we have 2 liters of water, as we see up here, there's going to be 1 kilogram for every liter of water. So that's a pretty simple math. Basically what this is telling us is that if we kind of equate this out, this is going to be telling us that the mass of the water is actually 2 kilograms. And this piece of information then can be used in the equation where we were missing the mass. All right, so where we are here back with our equation is we had this red flag, not knowing the mass, but that's actually going to go away. And we now do actually have this mass of water, so we can actually continue. So what I'm going to do here, I actually want to solve this thing for, the goal was to find the specific heat of metal. So what I want to do is I want to get this mass here and this change in temperature to this side. So the mathematics that I'm going to do is I'm going to divide by negative m sub m delta Tm. And again, since I'm doing that on one side, I also need to do it over here on this side. So negative mass m delta T m, and that crosses out here and here, leaving me with specific heat of the metal, which is what I want to find. And over on this side, I'm going to have m sub, oh, you got to be careful with these subscripts, make sure you're being really careful. That's mass of the water, specific heat of the water, change in temperature of the water, over the mass of the metal, and the change in temperature of the metal. All right. One last thing, change in temperature can be thought of as a final minus an original, and those are the two pieces of information I'm given. So let me get my pen here. Specific heat of metal equals mass of the water, specific heat of the water, and this will be my temperature final minus my temperature original, and that's all for the water. And on the bottom, we'll have the mass of the metal, and let's see, my final minus original for the metal. All right, so this is the equation. As I look back at my knowns, I do have all of the things here on the top, and I have all of the things on the bottom. Once I substitute these things in, it's going to allow me to solve for the specific heat. So I'm going to pick up, I'm going to have all that stuff written down and have solved it for you when we get back. All right, so here we are after I've substituted the numbers in. A couple things just again remember here is that all the information on the top was all water information. All the stuff that was on the bottom was for the metal. So we want to make sure that we're putting the numbers in the right place. You know, these were both masses here and here, but this was the mass of the water, this is the mass of the metal. These are the change in temperatures for the metal, and these are the change in temperatures for the water. And of course, this is the specific heat of water. After I do the actual math, I end up with, let's see, 1,860. Now, units for specific heat, of course, are a joule per kilogram degree Celsius. But let's actually take a look at how that comes about. And so what you basically look at here is look at the top and bottom of the fraction. You can see this kilograms, which is going to cancel out this kilograms. Inside our parentheses here, you're going to get a degree Celsius, so the degrees Celsius cancel out. And that leaves us with the joules per kilogram degree Celsius, which is what we expect for the units for a specific heat.